Hi, so in this video, I'm going to show you how to derive the formula for integration by parts, which is this formula here, and how to apply it to perform integration. So the first thing we need to understand is that if we have y, which is the product of two functions, u and v, and both of these are functions of x, then we have the product rule of differentiation. And this integration by parts formula comes from this product rule. So you can see on the left-hand side, we have the integral of u dv by dx, integrated with respect to x. So the first thing we'll do is we'll make u dv over dx the subject of the product rule. So we'll say u dv by dx is equal to dy by dx minus v du by dx. And now we'll take the integral of both sides with respect to x. So we have the integral of u dv by dx with respect to x is equal to the integral of dy dx, again with respect to x, minus the integral of v du by dx with respect to x. And now can you see that this dx and this dx will cancel, and the integral of dy will just make y. So we can write this as these two will cancel, so we have y minus the integral of v du over dx with respect to x. Now we said at the very start that this y is equal to uv, so we can substitute this into our formula. So we have the integral of u dv by dx with respect to x is equal to y, which is uv, minus the integral of v du by dx with respect to x. And this is the integration by parts formula. So in example 2, I'm going to show you how to use this to integrate a complex function. So we've got a copy of this formula up here just in case we forget what we're doing. And this is the integral we've been asked to find, the integral of x multiplied by e to the 3x with respect to x. So can you see that we're going to let u equal x, and we'll let dv equal e to the 3x. And we have our dx term here. So now we'll need to work out v. We have dv, but we'll need to work out v. We have u, but we'll need to work out du. So du by dx will equal 1. We've just we've just differentiated this x term. And now we need to work out v. But if we take the integral of dv by dx with respect to x, these will cancel, and we're left with v. So v will be equal to the integral of e to the 3x with respect to x. And this is, using the reverse chain rule, 1/3 e to the 3x. Okay? So I'm just going to put a little circle around these 4 terms, just so I don't forget. Okay, so now we want to work out this integral. And this will be uv minus the integral of v du by dx, integrated with respect to x. So u, we know is x. V, we know is 1/3 e to the 3x, minus the integral of v, which again is 1/3 e to the 3x, du by dx, which is 1, integrated with respect to x. So I'm going to draw a little box around this, and we'll do this separately. So we'll do this over here. So we want the integral of 1/3, which I'll move out in front, of e to the 3x with respect to x. But this is exactly what we just worked out over here. And we know that this is 1/3 of 1/3 e to the 3x. So this is this bit here. So we can go back to writing the integral. I'll move this 1/3 out in front. So 1/3 of x times e to the 3x minus this bit, which we have over here, and 1/3 of 1/3 is 1/9. So minus 1/9 of e to the 3x plus the constant term. Okay, so finally, we're going to tidy this up a little bit. I'm going to factor out this 1/9. So we have 1/9. I'll also factor out e to the 3x. So 1/9 of e to the 3x. So now I need to multiply this by 3 to get the 1/3 and the x. So we'll have 3x. And then we've got the 1/9 of e to the 3x. So we just need minus 1. And this is plus the constant term c. Okay? Let's try question 3. Okay, so for example 3, we're going to let u equal x squared. And we're going to let dv by dx equal e to the x. So now we'll need to work out du by dx, which is 2x. And we'll need to work out v, which is the integral of e to the x, dx, which is e to the x. So I'll just block this off. So now we'll substitute these values into our formula. We have uv, so x squared e to the x, minus the integral of v, again, e to the x, du, which is 2x, integrated with respect to x. I'll tidy this up by moving the 2 out in front of the integral sign. So we have x squared e to the x minus 2 times the integral of e to the x times x dx. So now we need to integrate e to the x by x, again by parts. But now it's much easier if we let u equal x, because when we differentiate that, we get 1. So if we say u is equal to x, then du by dx will equal 1. That means dv by dx will equal e to the x, and that will also be v. When we integrate e to the x, we get e to the x. So I'll draw a green line under this bit so we know what we're doing. So what we have is x squared e to the x minus 2, and now times the integral of e to the x, which is u. So x times v, which is e to the x, minus the integral of v e to the x du, which is 1. So again, we have x squared e to the x minus 2. And then we'll have a little blue bit under here, x e to the x. And then when we integrate e to the x, we get e to the x. So minus e to the x plus the constant term. So we can tidy this up. We'll factor out e to the x, and we get x squared minus 2x minus 1 plus the constant term. Okay? So in this example, we had to use integration by parts twice. Once for here, and then once for here. Okay, well, thank you very much for watching, and I hope you found that useful. You can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.